Hello everybody. Today's shout out is going to go to 3 people who actually wrote out the extreme bonus. Many of you did it during the live Zoom with me, but Nathan, Vaishnavi, and Emma actually wrote it out. Great job, guys. So today's goal is that you can solve a system that involves a linear and a quadratic equation. Remember, a system is just 2 or more equations together, and you are looking for the solution that works in both equations. So we're going to be looking for a solution or solutions that work in both a linear and a quadratic equation. So let's get started. So a system involving a quadratic and a linear equation can be solved 3 different ways. We can solve it by graphing. We can solve it using substitution, which will end up being the way that we use more often. Or we can solve it with elimination. When you're solving a system of a quadratic and a linear equation, you're looking for the place where the parabola and the line cross. So when you have a grid and you have both a parabola and a line graphed on the same grid, it is possible for the parabola to cross the line at 2 places. So this is an example of 2 solutions because the parabola touches the line twice. It's possible that the parabola just comes down and touches the vertex of the parabola, touches the line at 1 place, and that gives you 1 solution. Or it's possible that you draw a parabola and a line on the same grid and they actually never cross. And that would be an example of no solution. So we're going to first start with solving by graphing. And we're going to use the graphing calculator on Desmos.com. If we were in class, we'd be using the regular graphing calculators, but theoretically you could also graph both of these equations by hand to see where they intersect. But let's go to Desmos. And I have entered already the 2 equations. I entered the line in pink and the quadratic in blue. And you'll see that the parabola and the line never touch in this instance. So for this system, there is no solution. So now let's go back and look at some other methods of solving. So the main method that you'll be working with is substitution. If you have this system, here's my linear equation, here's my parabola, and I want to know where they cross. If y equals this, and y also equals this, that means that these 2 things would have to equal each other. So that's what you do. You substitute this for y in this equation, and you write one big equation. Your equation has the linear on one side and the quadratic on the other side. And it doesn't matter which side you put them on. But then you move everything to one side so that you can solve your quadratic, because to solve a quadratic, you need to have it equal to 0 if you're going to try to factor or use the quadratic formula. So you would be here. So then you solve it, and it gives you, you can solve with any method that you want, and it gives you 2 x numbers, or 1 x number, or no x numbers. If it gives you 1 x number, then you plug into your linear equation to get your y number to see where the parabola touched the line. If it gives you 2 numbers, if you get 2 values for x when you solve the quadratic, then you're going to have 2 points. So you're going to have to plug in both of those numbers into your line to get your 2 y numbers. So you'll see how that works in a second. Let's try this first example together. So for this example, if I know that y equals this and y equals this, I'm going to write one equation, and I'm going to write my quadratic on the front side and my linear equation on the back side. And now I want to move everything to one side so I can solve my quadratic. So I'm going to bring over the negative x as a positive x, and I'm going to bring over the negative 22 as a positive 22. Now I want to combine my like terms. So if I combine my x's, I get 8x. If I combine negative 15 and positive 22, I get positive 7. So now I have this, and I can solve it with any method I want to solve this quadratic. I'm going to try to factor it. So I would be looking for two numbers that multiply to give you 7 and add to give you 8. Those two numbers would be 7 and 1. So I set up my parentheses, x plus 7, x plus 1 equals 0. So now I'm going to use the zero product property, because if this times this equals 0, then either this equals 0, so I'm going to write x plus 7 equals 0, or x plus 1 equals 0. If I solve this equation, I would get x equals negative 7. If I solve this equation, I get x equals negative 1. Those are the two x numbers in the two ordered pairs where the line and the parabola would cross. So I now need to get the ordered pair. I need to finish it off by getting the y number. So to get your y number, the easiest thing to do is to plug it into your linear equation. So if I have negative 7 and I plug it in here, I would have negative 7 minus 22, and that would be negative 15. And then I'm going to put my negative 1 in, so negative 1 minus 22. Chop, chop, I get negative 21. So these are the two places where the line and the parabola would cross. Now for our next example, I'm also going to use substitution. So I'm going to write negative 8 equals negative x squared minus 2x. Again, it doesn't matter if you put the line here and the quadratic here, or vice versa. Now I'm going to move everything to one side. I'm going to bring the negative x squared over, so I have a positive a, and I'll have a positive 2x minus 8 equals 0. I'm going to try again with factoring. So I'd be looking for two numbers that multiply to give you negative 8 and add to give you 2. Those two numbers would be 4 and negative 2. So now I set up my parentheses, x plus 4, x minus 2. Now I'm going to solve each of these equations by setting them equal to 0. So x minus plus 4 equals 0 is negative 4. And x minus 2 equals 0 gives you positive 2. So I know the two x values are negative 4 and 2. And so now I need to plug in to get my y values. But if you look at this one, this says y is always negative 8. So this is actually a horizontal line. And so if it's a horizontal line, the y is always going to be negative 8. So I didn't have to do any work there. So these would be the 2 points where the parabola would cross this line. Now for the last one, I'm going to show you how you could use elimination if you prefer that method. So to use elimination, the equations are already set up nicely because you have the y's that you can get rid of. So if I subtract these two equations, my y's will get eliminated and I would get 0. Now here's the tricky part. When it comes to subtracting, you need to subtract x squareds from x squareds and x's from x's. There are no x squareds in your linear equation, so I am really doing 0x squared minus 2x squared. So I'm going to get negative 2x squareds. Then I'm doing negative 4x minus negative 4x, which gives us no x's. And then I'm going to do 3 minus 1 and get 2. So now I have this equation, and I'm going to bring my negative 2x squared to the other side, so I have 2x squared equals 2. Because there's no b number, I can solve this one just using square roots. So I'm going to divide by 2, divide by 2. So I get x squared equals 1. I'm going to take the square root on each side. And the square root of 1 is positive or negative 1. So my two x values, so my two places where that parabola crosses that line, are positive 1 and negative 1. I'm now going to plug into my linear equation to get my y number. So I'm going to do negative 4 times 1 plus 3. And I get negative 1 for that one. Then I'm going to change this to -4, and I'm going to get 7 for my other y number. So these would be the 2 points where the parabola and line would cross. If you solved your quadratic and you had a perfect square trinomial and it factored and just gave you one x number, that's when it would cross just once. And then if you solve it and you get to the point where you're solving it and you can't factor and you can't do square roots and you do the quadratic and your discriminant is a negative number, that's when there's no solution. And we just say no solution for that because the parabola and the line never cross. So go to Flipgrid, practice some examples, and then tomorrow you'll have your practice form. Have a good day.